So I'm trying to share this. Yeah. I hope you can see my screen now.
Yes, I see your window.
Okay. So yeah, and this is the, I'll share in the chat as well the link. So basically, a few minutes early on, I'll just uh, show how to use this, and briefly, few more minutes you can discuss something around it. I'll show you some resources if you're interested. You can look into that. And yeah, at the end of this thing, we should be able to use it and deduce something with the plots. So this website is hosted on Python Anywhere. It's an open source platform. So you just go to this website, and there are few options. So we want to do PCA, and you can see the first tab is PCA 2D and the other is PCA 3D. So basically, how do you use it? So I have one file here. Yeah. Yeah. So now, basically, if you see, the platform requires you to submit a file. It should be CSV format, and there is a screenshot here. Basically, it says that in this way you have to upload the file. So this, there is, you can see quantity 1, quantity 2, and it can be any n numbers of quantities, and you can name this anything if you want. If you see the last column, there is label written, and that is yellow marked. So this I have actually marked just to say that column of this name should be this only label. And for example, here you can see that I have just written, for example, if this is temperature, if this is solubility, these are some abstract values actually. This is pH value, say, and this is concentration. Then you can associate, say, this is A is some ion, A ion, B is some other ion, and similarly C and D. So what happens if we, yeah, so basically you come to the this portal, you choose your file. So, so you just select your file and you upload it. Faintly, you can see here the name. Uh, I mean, the background is blue, so, and it is written in black. So the moment you submit, you can see the cursor revolving. Yeah, now it gives you a downloads a file. You can save it anywhere. In my downloads. Yeah. Actually, yeah. Then you can open this. So you can see a plot in 2D. Okay, there's one second. I'll just be back. 1 minute. Okay. So you can see that here we had data which was 5-dimensional, and we could not deduce anything. What is happening here? So here we see that we have a plot in 2D. So here also, like since it was some abstract data, but you can see there's some difference in the pattern. So I'll show you one example actually where it actually mattered. Just now I'm showing you this example just to just execute it. So this was 2D. Oh, so what else you can do? So here, the moment you have the plot, You can click on export. Yeah. So here also you can do many things like yeah, you can just go here and go deep down, and when you click yeah, auto scale, it comes back to uh, you can do okay, same thing. Yeah, you can download also here. Say you want to download it, then it will download as a PNG file, this file. But say you want to put some name on the axes, then you can just come here, and there are many options like theme, style, annotate, legend, and you can like write here and you can change these things. And so this is how you'll get the plot for 2D. And say you want to do a 3D PCA. So simply you just so you get another file. So this is the you can actually rotate this. And yeah, you can take a snapshot wherever you want. You can run it. You can see the labels here. It can be whatever lines you have. So similarly, you can export this as well. And go ahead with post-processing. And after doing this, you can just delete the HTML files if you wish. Actually, there is a functionality of like you can just show the plot here as well, but you need to refresh your browser every time because it just gets into your cache and the old plot. Here also you can like there is option to export and you can do this, but that way also is fine. Okay. So this is how you use the tool. And so is there questions on question in this part? I think this is like pretty much clear. I'll share the this demo sheet also. Okay, in the chat. Okay, after the meeting, share it. So basically, a brief intuition about what is happening here is, for example, let us consider, say, our data is in 2 dimension. So here, actually, if you see just now the example I took, here was data is in 1, 2, 3, 4, 5 dimensions. So, but here's to explain, I'm taking just the case where you have 2 dimension and you want to basically do a PCA on that. Why would you want to do a PCA on that? Because PCA helps you see actually if there is some, you find an axis where the data are basically segregating or getting apart more. So you can find some pattern around. So if you see slowly, there's an axis revolving. If you see that this is the worst choice of axis, because if you see the, okay, so let me tell first that black is the axis that we are choosing. The red points are actually projection of all the blue points on it. So if you see that when I go, like the angle is going vertical, the blue, the red projection of the blue point uh, for many points is it's coming very close. So it's difficult to actually uh, characterize those perfectly. But as you go down, you can see the spacing is increasing. But as you further go, increase the angle, it is again like clustering more closer. So simply, this is the ideal place to be. So this is what we do in an n-dimensional vector space. Basically, we find an axis. So in where the points are mostly separated. So so few examples are. Yeah. So this will also, I'll send you a link. Basically, this was my. So I have a section where yeah. So there are few case studies in this. If you're interested, you can take a look. Basically, where they use PCA to actually uh, yeah find out basically what whether it is an alkane, ketone, or an alcohol. That was one example. The other was basically they try to find out in this one. Yeah, this is based on whether some food item has gone uh, basically is fouled or not. After a few days, we take the sample of basically what it has excreted out, and then taking a PCA on that, then they find a pattern. Yeah, so they find day one, they have some concentration of it, and in day 5, if you see the concentration really increases, then they do a PCA on that, and they reduce. So yeah, this example, they find which tea is better. There's a bit of theoretical background, not required. See. Mm, yeah, here also I have the pictures that you can take a look. Yeah, this one, I think we saw that after doing PCA that the fluoride ion had the maximum drift and the other ions did not. So yeah, we could conclude this. I'll share these links with Pavitra. Is there anything? Yeah. Mhm. Yeah. Anybody has any questions or? Should
I
be
think
clear, right?
yeah,
Yeah,
I
yeah.
think it's clear based on the like the web page.
Uh-huh.
Yeah, it's clear.
Mm-hmm. Mm-hmm.
Maybe you can
Uh,
share the thesis also with.
yeah, yeah. I'll share the thesis and yeah, the web page and the dummy files which I have.
Okay. And do you have any SOP for this?
SOP.
Like
Didn't get you.
oh, SOP, Standard Operating Protocol.
Okay, standard operating protocol.
Yeah.
I think in my thesis itself,
Okay, that would be
uh,
fine then. Yeah, then I can use
yeah,
it. Oh,
I think here I have mentioned that gist of this thing.
mm,
It's like simple when you just get it in this form and then you can plug it in whatever
okay.
you have, and you can have whatever you have here. So yeah, one few things. Okay, that's fine. Actually, few things is like don't when you have your file, right? So you have PCA data.csv, then don't have a space in that because I wrote the code way back. and it might crash. But if it yeah, because if there is a space or something, it will just throw you an error. And when you were writing the name of the columns, then yeah, don't keep don't start with a space or and yeah, here you just keep the name as label. Here you can change whatever you want. I mean, here also it's mentioned here. You can check the yellow things represent that, and the input format should be CSV, and then all should be good. Like last 2 years, I think Sutripta was using, and there was no issue. We're fine. And if there is some issue, just shoot me. I'll share my email also.
Yeah, that would be good.
Mhm. Okay, then if there's no questions, then I'll share all the details in Pavitra and she'll share with you guys.
Okay, thank you. Are there any questions?
Yeah,
Like,
thank you for attending. Yeah, if there is. Yeah.
yeah, I just
Actually,
wanted to
like
know.
yeah, if someone want to explore some other, there are many other methods you want. You can reduce the dimensions, and PCA happen to be a linear method. Uh, where it is assumed that the axes are like the features are uncorrelated. So there are other methods like kernel PCA and LDA. There are different methods. If anyone is interested, can look into those areas also. And if you want to discuss something, then happy to. Okay, then.
Okay. Thank you,
Thank you.
Yash.
Yeah, yeah. Thank you.
Thank you everyone for joining the session.